boys and girls. Welcome to Science for Life for grade 4 pupils. I am Dearani Narain, and today we will learn more about science. So get ready to have lots of fun because science is cool, it's awesome, and it is all around us. Remember to investigate, explore, and ask lots and lots of questions. Now our topic for today is based on soil and their properties. By the end of this session, you should 1. Define soil, 2. List the types of soil, and 3. State the properties of each type of soil. Facts you need to know about soil. Soil is the top layer of the Earth's surface. It is made up of particles of rocks and minerals mixed with parts of plants and animals. There are 3 types of soil. These are sandy soil, loam, and clay. The decayed part of plants and animals found in soil is called humus. Humus adds nutrients to the soil. Loam has the most humus, therefore it is the best soil to use in our kitchen garden. A simple experiment will be done to identify the size of the soil particles and the water retention. Materials needed to conduct experiment. 1. We needed the samples of the soil of the 3 types, sand, loam, and clay. 2. Water. 3. 3 clean and clear containers. 4. Measuring cylinder. 5. 3 Petri dish. 6. 3 plates. And 7. A stopwatch or a clock. Okay. So here we have the things that we need to conduct the experiment. We have our samples of soil, we have the sand, loam, and clay. We have sand, loam, and clay again. And here, instead of using a measuring cylinder, we're going to use these cups here. So when we pour the water into the soil, we're going to put it in here to measure it to see how much water will drain after a minute or so. Now these samples that we have here in the Petri dish, we're going to observe to see the size of these particles. First, we're going to start with the sand. If you notice the sand, when you touch it, it's loose, right? And if you look closely at the particles, you could see they are very coarse, or you could see that they're large, right? So this sand, we could say it's large, so we're going to label it as large, right? When we look at the loam now, the loam here, compare it to the sand, if you look closely, it's not as large as the sand. So we could say the loam is medium size. So we're going to name it medium. So we have large, medium. And when you look at the clay now, it's something like powder. So it's very, very fine. So the particles that makes up the loam are very small, right? So the size of the particles, when compare them, the sand particles are large, the loam particles are medium, and the clay particles are small, right? Now, we also have to look at water retention. Now, to do water retention, we're going to pour some water into the container with the sand. I'm going to put it over here for it to drain, right? I'm going to use a plastic cup, and I measure it here. I marked it for us to use the same amount of water in each container. Now, what I did, at the bottom of each container that has the soil, I made some holes underneath here so the water will drain. What I will do also, I will also use a 1-minute timing to allow the water to drain. So I'm going to use my phone to time myself. I set it on the stop clock, and so I'm going to pour the water here I'm going up to the mark there. So I pour the water into this cup here, and now I'm going to use my stopwatch. As soon as I start pouring the water, I'm going to put my stopwatch to start. So I'm pouring, and I'm hit start, and I start to pour. Remember, I'm working with the time, so I'm going to wait until 1 minute to remove the container with the soil, with the sandy soil especially. So I am exactly 1 minute. Here now, you could see the amount of water that was drained from the sandy soil, right? So within a minute, we have this amount of water drained. So we're going to do the same thing for loam. So we're going to use our measuring cup again, pour the same amount of water. I'm going to reset my stopwatch, and I'm going to put this over here. So as it drains, it's going to catch the water into the container. So I'm going to put my stopwatch to start, and I'm going to pour my water in. Good, it's 1 minute, so I'm removing the water and I'm placing it here. So we could see the amount of water that was drained after 1 minute. So we're going to do the same for clay. I'm using the same amount of water again. I'm resetting my stopwatch, and I'm going to place this over here so it will drain, and I'm going to pour. Start, and I pour. If you notice with the clay, it's taking a longer time for it to drain. There, 1 minute is up. So we have the results here of the water retention. When the water was poured in the sand, you could have seen the water pouring out, right? So it did not hold the water for a long time, right? So the sand cannot hold the water. So it does not have much retention, because remember at the beginning we discovered that sand particles are very fat, or you could say they are large. And because they are large, they have a lot of air space, right? And the air space in between them allow the water to flow through easily. So that is why it could not retain the water. Now, compared to the loam, the particles are not as large as the sand. It's medium size. So there is less air space between these particles. So that is why we have the loam has the less amount of water retained. And look at the clay now. The clay, the particles are very fine, so they're small. So there isn't any air space for the water to flow through. So when we were trying to drain the water from the clay, hardly any amount of water came out of it, as you could see in the container here. Right? So we could say that sandy soil cannot retain water easily. The loam will do so, but the clay soil retains water for the longest time. So let's go back what we've learned today. We learned that sandy soil, the particles are large and they do not retain water, right? Loam, the particles are medium in size. It retains water but not for long also. And clay, the particles are very small and it retains water for a very long time. So let's go it back again just for you to remember. Sandy soil, the particles are large and the water drains quickly. Loam, the particles are medium size and the water took a longer time to drain. And clay, the particles are small in size and the water took the longest time to drain. Now as you look there on the screen, we could see sandy soil, loam and clay. When you look at the sandy soil particles, you could see the air space between these particles. That is why we said the particles are large. And the loam, the particles are medium size, so it has a small amount of air in between. So when you pour the water, it has a small amount of space that it will pass through. And the clay, there is not much air space there, so the water lingers at the top of the soil. Now, plants that grow best in each type of soil. Now, in the sandy soil, you can have peanuts growing there, the cactus plant, and carrots. Those are just some examples. For the loam, you have bora, okra, pepper. Now, the loam can be used in your kitchen garden. So think about all the plants that you would plant in your kitchen garden, and those plants will grow best there because the loam has a lot of humus inside. And remember we said earlier that humus are the decayed remains of plants and animals, and the humus helps to make the soil fertile, right, or nutritious for the plants to grow. And then we have clay. And one plant that grows best in clay is rice, because the rice needs a lot of water. So the clay retains the water for the rice to grow. What did we learn from this lesson? Soil is the top layer of the earth's surface. It is made up of particles of rocks and minerals mixed with plants and animal parts. There are three types of soil. These are sandy soil, loam, and clay. Sandy soil has large particles and drain water quickly. Loam has medium-sized particles and the water takes longer to drain. Clay has small particles and the water takes longest to drain. The decayed parts of the plants and animals found in soil is called humus. Humus adds nutrients to the soil. Loam has the most humus. Your task for this lesson. I would like you to draw and label the layers of the earth. Here's a look how it should be. Here we have the earth, and it looks like a part of the earth was scooped out, and you're going to see the outer layer as a crust. After the crust you have the mantle, then you have the outer core and the inner core. That brings us to the end of this session. Hope you learned a lot from the experiment. Remember, you can try this at home to have a better understanding about soil. Goodbye, children. See you next time.